Welcome to the first course of this series, Introduction to Building on the Theta Blockchain. My name is Jeremiah, and I'm going to take you through this series. This series will include a Theta Blockchain overview, how to access Theta's public APIs, followed by smart contract basics, then deploying a TNT and NFT contract on the Theta Blockchain, creating a DApp to interact with your contract, and then we're going to get into some AI stuff, the Theta Edge Cloud and on-demand models, how to run Comfy UI on a community node, and how to run Olama on a community node. In this first course, we're going to look at what is a blockchain, what is the difference between a hard fork and a soft fork, how data is stored on the blockchain in your wallet versus in a contract, and using an API to access data that is stored on the blockchain. So, what is a blockchain? Now, when I first started going to crypto conferences years ago, it was really scary. Like, blockchain is cool, it's new. What is it? A lot of people didn't fully understand it. There wasn't a lot of documentation. So, what exactly is a blockchain? Well, a blockchain is simply blocks that are built on top of each other, one after another, after another, after another, that stores data. And because you know the next block is in the chain, you can go back at any point in the chain and pull data out of it and trust that that data was written at the time it says it was written. So if you were to create a database, you could simply write data into it and pull data out and replace data at will. With a blockchain, whenever you replace data on the blockchain, there is a record of the exact time and block that that data was put into it. So a blockchain is simply, when you think about it, is blocks. One block built on top of another block, on top of another block, on top of another block, and it stores exactly when the data was sent into the blockchain. So when we create a chain, we create a block, and this first block, it's going to look like a lot of data here for you guys, is 1, 2, 3, 4, 4. And the block underneath it is 1, 2, 3, 4, 5. And as you can see on this first block, 1, 2, 3, 4, 4, the hash ending in 187A1 is then the parent for the next block, and that ends in A187A1. So when you are creating blocks in the blockchain, the hash of the current block then becomes the parent for the next, and so on. So if we had the hash showing down here, that would be the next one for the next block of the parent. Next, let's look at what the difference between a hard fork and a soft fork is. Now, sometimes hard forks happen by accident, so not every hard fork is intentional. Somebody can do an update and the blockchain can have a hard fork. So first we're going to look at soft forks. So what is a soft fork? So you have your blockchain here and it's creating blocks, it's chugging along like it's supposed to, and then somebody wants to do an update or change some rules, add some new code to the way the blockchain functions. For example, we want to increase the fee on the blockchain. So then we need to create some new rules. So what happens is at a specific block in time, the blockchain will change and these new rules are implemented. So the blockchain then goes back up here and it's still the same chain, but it just has new rules on it. So a soft fork is you simply make a change to the current blockchain, and to the user, to the end person like you or I, nothing changed with that blockchain. It's still Ethereum, it's still Theta, it's still whatever your favorite blockchain is. Now a hard fork is a lot different. What a hard fork is the blockchain is creating blocks and it's chugging along, and something happens where a second chain gets created. Now this second chain can be created by accident or it can be created on purpose. So a good example of a blockchain that is created on purpose would be when Bitcoin was hard forked off into Litecoin, or when Bitcoin was hard forked off into Bitcoin Cash. You have the Bitcoin blockchain, which continues on, no problem, and then you have your new blockchain that continues on with the new currency. Example of an accidental hard fork is we're all using Node version 3.0, for example, and somebody comes out with Node version 4.0, and it's not supposed to be a hard fork, but it makes a change in the rules. So everybody that continues to run 3.0 is now on the original chain, and everybody that upgraded to version 4.0, for example, is on the new chain because there's new rules, so there's a new chain. So hard forks can be intentional or they can be created by accident. But basically, it takes the block and creates a new chain from that specific block forward. So on the new chain, all transactions before this block are going to be the same on both chains. Next, let's look at how the blockchain stores data. So how does the blockchain store data? Is it a wizard that is just holding up his crystal ball saying, put the data in here? Or is there more to it? So, what is stored on your wallet address? All that is stored on your wallet address in the Theta blockchain is how much Theta you have, how much Theta you have staked, how much T-Fuel you have, how much T-Fuel staked, and what sequence number you're on. And the sequence number is just simply how many transactions have occurred in your wallet. Any token data, such as NFTs or TNT20 tokens, are stored in the contract address. So they are not actually stored in your wallet. They're stored in the contract itself. So if you want to see if you own a specific token, like let's say T-Drop, you are simply going to send your address to the T-Drop contract in a function, and the T-Drop contract is going to kick back how many tokens you own. And the same thing goes for an NFT. You're simply going to send your address over the NFT contract, and it's going to kick back if you own an NFT and what number that is. Now let's take a look at how it works on the blockchain. So when you go to your MetaMask wallet or over to ThetaScan or Theta's Explorer, and you enter your wallet address, so we're putting our wallet address in, it has to make a call to the blockchain to token contract 1. Token contract 1 will return you have 100 tokens. And then it's going to go and make a call to token contract 2. Token contract 2 will return that you have 10,000 tokens. And then it's going to make a call to the NFT contract that's in there. And the NFT contract will return you own NFTs 3 and 5. So when the Explorer or MetaMask kicks back that, hey, you have these wallet balances of Theta and T-Fuel, that was one call to the blockchain. When it returns back, you have a token balance of 100 on the first contract. That was the second call to the blockchain. And then when it turns back, you have 10,000 of token contract 2. That's a third call to the blockchain. And then your NFT contract balance will be a fourth call to the blockchain. So to get all this data, it's making 4 calls. And if it's checking like hundreds of tokens, it could be hundreds of calls to the blockchain just to get your wallet balance. Now let's look at how to get blockchain data. So in order to get blockchain data back, you are going to have to use an API. And in this video, we're going to go over how to get blockchain data, not how to write blockchain data. So how to get blockchain data is you can use Theta's scans API, and you can get the balance. You can enter a hash and return the transaction details. You can get a block. You can get the stake, like how much T-Fuel or Theta you have staked. You can get the average block time of the network. You can sign a raw transaction and send it to the blockchain. And for this class, it is not covered. You can go through the transactions and return transaction information. You can get the market cap of Theta or T-Fuel. You can get the current price of any Theta, T-Fuel, or TNT20 tokens. You can get contract details for a TNT20 or an NFT. And then there's a full ETH RPC provided for MetaMask. So if your app requires you to use MetaMask, there's ETH RPC on ThetaScan. Now let's take a look at Theta's Explorer APIs. So from Theta Explorer, you can get the blocks. You can get the blocks by range. You can get the transactions. You can get account details, which would be get your balances. You can get the staked amount by address or all staked amounts. You can get the Theta or T-Fuel amount, like how many exist on the blockchain. And you can get a token summary or a transaction summary. So as you can see, different APIs will have different calls that you can use for your project. Next, let's take a look at when you call the same data from different API, how it will return slightly different results. So for example, if you go to Theta Tokens Explorer and ask for block 12344, it's going to return it in the body as a type block, and the hash is going to be end in 18781. So it's returning you the data you want, but you're going to have to go to body and transactions to get the transactional data. Now if we call that same block from ThetaScan and we call block 12344, it's going to be inside of block 12344, and we come all the way down here to hash, and it's going to be 187A1 as the hash number. So you're just giving me the same hash number, the same data, the same 12 transactions are in both. If I go back here, we have the same 12 transactions in both, but on ThetaScan, it gives you slightly more information in a slightly different way. So let's take a break from those slides, and we'll come over here and try it in the real world. We will take a look at some data on the Theta blockchain. So we're going to go to ThetaScan to start with, and we're going to go to Developer API, and then we're going to scroll down to block number, and we are going to copy this API call, which is just asking for block 12344, and I'm going to paste it into a new window, and it's going to give us a whole bunch of information. As you can scroll down, when you make this call, it's giving you tons of information. Alright, so let's shrink some of this down. So these are all the validator nodes that are voting on it. We'll get rid of those. And we'll get rid of transaction 0, and we'll just take a look at transaction 1 in this. So it's saying that it costs somebody 1,000,000 T fuel to make, which on the blockchain, this number is always to the power of 18. So you would remove 18 zeros to get exactly how much T fuel it costed. And the same way with Theta. And the coins that were transferred were 65, and you could count over how many zeros that is to see if it's 65, 6.5, 0.65, 6,500. And this was the first transaction that this wallet has made. And this is what is included in a block on ThetaScan. Next, we will go to docs.thetatoken.org/docs/explore API reference. And this is where we find the calls here. And they're going to give it to you as a curl. So you can make that from Linux or from DOS if you have curl available. If not, we just copy out the address here. And we're going to simply paste it back in here. And we're going to make the block number the same. And it's going to return slightly different information here. So as you can see, we have the body. We have transaction 0 and transaction 1, 2. And everything is drastically trimmed. So their Explorer is trimming the data before you get it, where ThetaScan is giving you the full data from all previous blocks. And while we're here, let's do a balance check. So we want to come over here to the table of contents, and we are going to go to get account, and we are going to copy this out, and we're going to paste it here, and we're going to change the address to the same account that is here. So we have the same account number. Paste that in there. And then we're going to paste this in here. And we'll compare the two. Alright, put them next to each other. So on Theta's Explorer, you're going to get the address, the Theta We balance, the T Fuel balance, the sequence number, and then you're going to get what they call a transaction counter, and it's going to have 0, 2, 7, 8, and 9. So they're keeping track of how many smart contract interactions and how many staking interactions you made, because these transaction counts are the transaction types. So 2 is a send, and then 7 is a smart contract, and then 8 and 9 are staking and withdrawals. And if you go to ThetaScan for the same balance, it's going to have 10 Theta, and then what is that, 2.7 million T fuel, and it's kicking it out to you in a different one, but the sequence number is still 328. And if you come over here, the sequence number is still 328. And as you can see, they don't put the decimal place in there and give it to you in we, which is just to the 18th power, and T fuel in we also, where ThetaScan kicks it out as a whole number with a decimal point. Finally, let's take a look at how to make an API call in JavaScript. Now, for your project, you don't have to use JavaScript. You can use Python, C#, C++, PHP, whatever makes sense. But for this course, I'm going to teach you JavaScript since it can be used in any web browser across any OS. So what we're going to have to start off with is giving it a URL to call, and we're just going to use ThetaScan's block URL. So we're going to get block 12344. We're going to fetch the API URL. So we're going to go to this URL and fetch it, and then we're going to wait for a response. If the response is okay, we're going to continue on, and it's going to kick out the JSON that it returns. If it doesn't give us a proper response, then it's going to give us an error in the console window. And next up, we're going to take the data that we got from the response, and we are going to console log that we fetched that data. And if there's an error printing that data in the console log window, we are going to say what the error number is and what's wrong. So when we run this in our Explorer, it will console log out the block number that we just called for, 12344, and it'll give us that the chain's on mainnet. And if we come down here to the hash, it is the same hash, 187A1, and it has the same 12 transactions in it. So your application can then pull whatever data you need from the blockchain using JavaScript. Now let's test out what we just learned. So we are going to make a new text file. We're going to call it test, and we're going to open that, and then we're going to paste in our JavaScript, and we are going to save this, and we are going to rename this to HTML, and it's going to warn us that it may be unusable, and now it can be opened in our web browser. So we are going to open with Firefox, and as you can see, nothing happened. So we press F12, and we open up our console log window, and we have fetch data, and we have our object, and we have our block 12344, and it's kicking us out the same hash, 187A1, and our 12 transactions, which are all right here. And this is how you use JavaScript. Last, let's take a look at if you want the user to press a button and then it fetch the data from the blockchain. So if somebody has to do something on the web page before it just grabs data, because you probably don't want your application just grabbing a bunch of random information from the blockchain. So we'll shrink this down, we'll go back into test, we'll reopen it in Notepad, and we'll push our script to the bottom here. We'll make a couple HTML tags real quick, and then we'll just simply add a button, and we'll give it an on click, which basically says that it'll call a JavaScript function for us, and we're going to name the JavaScript function call. And we'll name the button get block 12344. And now we're going to grab the function call, and it's going to get block 12344. Now this needs to be put in a function, so let's put it in a function. And we have it in our function, so everything looks good, except fetches have to be in asynchronous functions, so you need to add asynchronous in front of function for this to work. So then we're simply going to save it and close, and then we're going to open this up into Firefox, and we have our button here, and we press F12. We don't have any data yet. Then when we click on the button, it will call the API, and it's fetching back that it's mainnet, and the block number is 12344, and it has the exact same hash, 187A1, with our 12 transactions that we got earlier. Now I'm going to shrink this down, and every time you click this button, it is going to fetch the same data from the blockchain. So it's all fetching block 12344. And this will end our first class on Theta's blockchain overview. If you need to go back and pause the video, run some of the examples yourself, or if you need to rewatch it 3 or 4 times in different spots so you really grasp some of the concepts that are in it, that's why it's recorded as a video. So do that. The next video in the class is going to get very, very technical into Solidity. So make sure you guys understand this, and I look forward to seeing you guys at the next class. Thank you for watching.